we need to sketch the functions of f of x and g of x. So we have two different equations that we're drawing here, 2x plus 2 and 5 to the power of x minus 1. And we're asked to sketch it between minus 5 and 5 for the x values. They've also given us the y values as minus 5 to 5 as well. So when we go to our calculator, we can keep that in mind. So we have two equations to plot. 2 times x plus 2. And then my second equation, which is 5 to the power of x. And then it's minus 1. And again, just double check your equations look correct. Okay, it's often that people do like the minus 1 to the power, so always check it. We're going to graph it, and then we're going to change our window to what we've mentioned is on the exam paper, which is negative 5 to 5. And then again, for the y-axis, negative 5 to 5. Okay, so we can see what it looks like now. And we're literally just going to copy that onto our exam paper. So for the first one, we can see that the linear equation, f of x, it goes between, it crosses at 2 and it crosses at 1. Okay, and it has a gradient, which we know anyway from the equation of 2. Okay, so the gradient there is 2. So we're just going to draw that line on with a gradient of 2. Okay, so it looks something like this. Yours will be a little bit neater than mine. And then we have the second equation, which is the exponential to the power of x. And we can see that it goes through the origin and it curves up like this. Okay, now it actually crosses our blue equation before the end of the graph at around about 4. So I'm trying to make sure it looks about right for those values. So for this one, there are 3 marks. One of the marks is given for the linear line, which is the blue one on mine. One is drawn for the exponential for the general shape. And the other is for the exponential, making sure that it goes through the origin. And then the second part is to solve f of x equals g of x. So it's asking me to find these two intersections. Okay, so I'm finding those two intersections. So again, on my calculator, second function trace, and I want to find the intersection. And I'm going to scroll down towards the one on the left-hand side. So enter, 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 so 3 times. And we can see that the intersection there is that x is equal to minus 1.45166, or to 3 significant figures, minus 1.45. And then the second one, we repeat the same process, second function trace, intersection. And for this one, we're just going to go a little bit closer to this the right-hand side intersection, and we can see there that it's just x is equal to 1. Okay, so I've written it down. When I write it, it needs to have just the x value. So it's just x equals minus 1.45 and x equals 1. So that question is 2 marks, and it's just one answer for each of the correct solutions. And then the very last part is to write down the interval of where f of x is bigger than g of x. So that means that when I look at my graph, my f of x, which is my blue one, should be larger than the green graph. So if I take, for example, this value of x, the blue one is larger than the green one. This value of x, the blue one is larger than the green one. This value of x, blue one, green one. Whereas if I picked something like here, then the green one is actually bigger than the blue one. Okay, so I'm only interested in when the blue is the larger graph. And that's when I'm looking at the y values. So it's between these 2 points that I've just found. So it's in between the two. And therefore I can write my inequality using those two values. It's not equal to, it's just bigger than, less than. So I'm going to have minus 1.45 and 1, and it's when x is between the two, and it's not equal to, it's just less than. So it's when x is bigger than minus 1.45, which is this value here, and when it's smaller than 1. So when it's in between, that's where the blue graph is greater than the green graph.